This is the piston engine that powers the drive system on R-44 helicopters. In this arrangement, the engine is directly connected to the lower drive pulley. This lower pulley then uses 4 banded V-belts to power the upper pulley, and the upper pulley then transfers power to the main and tail rotors. But the pilot needs the ability to engage and disengage an operating engine from the drive system for engine start and shutdown. To do this, the aircraft is equipped with an electric clutch actuator that moves the upper pulley up and down. This actuator loosens the V-belts to disengage the engine and tensions them to engage the engine. Before starting the engine, the pilot disengages both the clutch and the rotor brake. With the engine now operating, the pilot engages the clutch actuator in order to raise the upper pulley and tension the V-belts. With the V-belts in tension, the engine now powers the upper pulley and the rotors. And after landing, that same clutch actuator is used to lower the upper pulley, which loosens the V-belts and disengages the engine from the drive system. Even though the entirety of the drive pulley and V-belt mechanism is called a clutch assembly, this is not the same thing as the Sprague clutch. The Sprague clutch, which is necessary for autorotation, is housed inside the upper drive pulley, and this device automatically disengages the drive pulley in the event of an engine failure. This animation is intended to represent a Lycoming IO540 installed in an R-44 helicopter. And if you're savvy about aircraft engines, you may have noticed I made a mistake when I modeled the engine. And rather than fix it, I decided to rebrand it as a feature. So here's a challenge. If you think you know what's wrong with the design of the engine, please let everybody know in the comments. I'll do a follow-up video and tell you what the foobar was, and also give a shout out to the folks who spot the mistake. Some orientation may help. In the R-44, the engine is mounted in reverse from what you'd expect if you're familiar with fixed-wing applications. This is the crank flange. When the engine is installed in an airplane, this is where the propeller is attached. And this is the number 1 piston. If you're new to my channel, I publish incremental videos as I create these 3D models, and I use your feedback to improve the designs and the animations. Once I complete this R-44 model, I intend to do a series of long-form videos to explain concepts of helicopter systems, controls, and aerodynamics. The questions and comments you're posting to this site will help me as I come up with the content for these future videos. Thanks for watching, and I'll see you on the next video.